is the secant tangent problem. Right? We're talking about the secant tangent problem. So I'm going to typically see my function, right? And I would love to find at C the slope of the tangent line. And I like to think of myself here as I'm skiing. Right, got my music on, skiing downhill. It's definitely a bunny slope. My girlfriend is a double black diamond skier and snowboarder, but I'm the bunny slope guy. I wanted to be close to the bar. So, but I'm skiing down the hill, right? And I'm trying to calculate the slope of my ski. Right? You understand what's going on here? But the problem is what? How many points do I have? How many points do I have on that line? One, right? I don't know how to calculate the slope with only 1 point. So what we do is we create a secant line. Oops. Right? The secant line hits 2 points. Yes, you with me? So that I can calculate that slope, right? But then what do is I move this point, right, closer to C. So I move it to here, then to here, then to here. And look at what's happening to those slopes. They're becoming the slope of the tangent. The slopes of those secant lines are getting closer and closer to the slope of the tangent. And guess what? Can I get to 1 point? No, but what can I do? I can predict. I can predict what the slope of the tangent line is. In pre-cal, right? In pre-cal, you did this secant slope. Do you remember what we called it in pre-cal? It sounded like a Dairy Queen, DQ. Remember what we called the secant slope in pre-cal? DQ, remember that? It's the difference. What is it? Different quotient. So difference meaning what? What is it? What's the difference in that? Subtraction. And what's the quotient? Division. And you already know that our secant slope we would like to call M, which was y2 minus y1 over x2 minus x1. So you can see upstairs I have my difference, and then I divide with a quotient, right? I get my quotient, a difference quotient, yes? How many pre-cal last semester? How many of us pre-cal last semester? How many of us pre-cal more than a year ago? How many of us never took pre-cal? Anyone never take pre-cal? Okay, so, all right, how many of us pre-cal less than a year ago? It's not adding up. How many of you took pre-cal? Okay, thank you, that's fine. So the difference quotient, right? But look at what I'm going to turn this into. I'm going to turn this into f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. In fact, I'm going to change it again. Wait, we recognize this, right? This is simple, yes? Yeah? This is simple. This is slope, right? Yeah? So what I want to do is I want to change it again. I want to call my first point x and my second point x plus h. So this distance here is h. Yes, you with me? Good. Give me my new version of slope. F of what? Nice. Beautiful. All divided by? Nice. What simplifies? H. So we'll say that the slope of the tangent line equals the limit as h goes to 0 of the slope of the secant line. Right? We also like this, f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. And what is that f prime called? What do we call that? Who remembers? Derivative. The derivative. The derivative is a function that will tell me the slope at any single point on the curve. If it exists, it has to exist. Right? The derivative is the function that tells me the slope at any point. Right? This is simply slope theta. And then what am I doing? I'm moving the points closer to each other. Right? All right, so let's take a look at their textbook in 2.1. For section 2.1, I'd like you to do numbers 1 through 5. No, 6 is good too. But I only gave you answers. No, did I give you odd answers I gave you, right? So whenever I tell you I like a certain section, do the odds. Right? You can see these 20, 30 hours come. Arsaman, what's up? Yeah. Always. I am never in a rush. I'm Polish, not Russian. Yeah. You ever see that show on public television? I can't remember his name. Brilliant. And he goes in people's past and finds out the family history. And is it the one where Cooper said, "I'm glad my great great grandfather died by a slave"? Yeah. I think it's like Finding the Roots. Anybody ever watch that? I love it. So, but I'm one of the lucky few that can trace my family, back, I think, 4 generations. World War One, but Polish, Irish, English, Lithuanian, English, Slovak, French. Anyway, finding your roots. Got to check it out. Parkman, you got what you need? Yes? No? Yes? You got what you need? Good. So in 2.1, I like 1 through 5. Yes? One of them you're turning in, correct? One of them you're turning in on paper. In 2.1, number 5, you're turning into me. Yes? So far you've got 4 problems due Monday. Notice I said complete the problem as it's written in the book, but also include a limit to verify the instantaneous velocity. We talked about secant tangent in terms of average velocity and instantaneous velocity. Yes? I live 10 miles from here, and it takes me an hour to get to work. That's the average speed, 10 miles an hour. Yes? But when I got the speeding ticket, right? Two quick pictures, almost so close to each other, right? Don't see it blink twice, right? They're getting my instantaneous. I got a ticket there, 150 in a point one. So, but I did it just for the class. You can write it all. Yeah. Sir, you were supposed to send us money, not a calculation. So let's take a look at number 3. In number 5, by the way, I'm throwing a ball up in the air. And it's, right, so I throw it up in the air, it's going fast, and then what's happening is it goes up. Slows down. And at the very top, right before it comes down, what's the speed at the very top? 0. And then it starts coming down and it starts to speed up, right? And so you're trying to figure out secant slope, average velocities, and then instantaneous velocity, tangent slope. So number 3 is very similar. Hard to see it, sorry about that. I've got the point 1, 1/2 on the curve y equals x over 1 plus x. I don't know what this looks like. Whenever I'm in that situation, I'm going to Desmos. Thank you, Dr. Early.
Oh, thank you.
Whenever I'm in that situation, I want to go to Desmos. F of x equals x over 1 plus x. And I want the point, what was it, 1, 1/2? There it is. I want that tangent line. I want the slope of that tangent line at that particular. And what can you see already? What's true about that slope? What kind of number is it? Positive for sure. And less than 1, right? So when the graph things, we get hints, right? We get a nice visual of that. So if you're one of those people that hates graphing, get over it. Right? When you do Calc 2 and Calc 3, you're going to be all crazy graphs in 3D, right? So you need to be comfortable with graphs. So I want the slope of that tangent line. So this is 2.1, number 3. So what I'm going to do is I'm going to pick another point out here, and I'm going to call it x f of x. Yeah, if anyone needs paper, you need paper? You okay? No, okay. If anyone ever needs paper, and I'm asking you to use a lot of paper for homework, and always take some paper home for homework. I made a mistake, sorry. Oh, no, I didn't. But I don't want this to be, do I want it to be x and f of x? Give me 1 second. No, I want it to be x plus h and f of x plus h, sorry. So that's the point 1, 2. This is the point x plus h, f of x plus h. Yeah? And h is the distance between x values, right? The first x value is 1. The second x value is x plus h. 1 plus h, really, right? Maybe I don't want x plus h. I want... Damn it. No, that's fine. Sorry if I'm confusing you a little bit, but you'll be fine in a minute. So I want to figure out my slope, right? So it's f of x plus h minus f of x all over h. We already figured that out, right? But f of x plus h is x plus h over 1 plus x plus h. And f of x is 1 over 1, x over 1 plus x. Yes, you with me? Sorry if I'm confusing you, all over h. So notice what I did there. I took my function x over x. Oh, I'm sorry, 1 plus h, right? 1 plus x. God, come on, Robert, get it together. Sorry. There it is. Right? And look what I did here. Instead of x, I wrote x plus h. Instead of x, I wrote, right, 1 plus x. Instead of x, I wrote x plus h. Yes? Minus the function all divided by h. Now, I know x and I know f of x, don't I? Don't I know x and f of x? 1 and 1/2? Yes? So I get 1 plus h over 1 plus 1 plus h minus 1/2 all over h. I get 1 plus h over 2 plus h minus 1 over 2 all divided by h. I'm going to call that star. So the slope of the tangent is the limit as h goes to 0 of star. I may have confused you a little bit, but yeah, question. Yeah. Yes, and if I'm going too fast, don't let me run you over, right? I jumped ahead a little bit. Section 2.6, where I keep the functions arbitrary. Don't put points in. That's when I'm going to find the derivative. Since I'm just trying to find both answers, I want to put the points in there. So I know. Right, I know the value of x, and I know the value of f of x, so I really wanted to kind of start here. Now h is going to 0, right? So 0.1, 0.01, 0.001, we will have you do that. So say calculate the slope for h is 0.1, 0.01, 0.001. So make sure you do that. But we want to just do this limit, because we know how to do limits. We learned it yesterday. So I want to manipulate star, right? Somebody help me. What do I have? 1 plus h over 2 plus h minus 1/2 all over h. What's my LCD? 2 times 2 plus h. And I want to do that over itself. When you see fractions within fractions, you want to make a single fraction where the numerator and denominator are single factor terms. How do I do that? By multiplying by the LCD. So what happens? I get 2 times 2 plus h times what? 1 plus h over 2 plus h minus 2 times 2 plus h times 1/2 all divided by 2h times 2 plus h. Everybody with me? I'm distributing this piece in each fraction, each numerator in the numerator, and I'm just distributing this in here, and I'm not going to simplify. You'll get, as you do more problems, you'll get when do I simplify and when don't I simplify. The same way you've got if something's a cat or a dog, right? How did you figure out if it's a cat or a dog? Does anyone teach you what a cat or a dog is? Just by looking, just by doing, seeing a bunch of examples, that's how we pick things up, right? I walk down the street with my dad and I say, look at that cool car, and he'd smack me and say, no, that's a truck, right? Eventually, he smacked me enough. I got enough problems wrong, and I started figuring out what's going on. Look at that. Look at that Eldorado. Now look at that truck. He's smacked me and say, no, that's an Eldorado. All right, what cancels here? The 2 plus h's cancel and the 2's cancel. And I'm taking my time here and rewriting. Notice downstairs is factored. That's what I want. The upstairs is not factored. Everybody with me here? So I'm going to try and distribute and see what happens. Now everything's factored. At this point, can I let h go to 0? Can I let h go to 0? No. 0 and then 0, right? I get 0 over 0 again. But now that it's factored, I can cancel, right? So I can cancel my h's here, and I get star is 1 over 2 times 2 plus h. Now I can let h go to 0. This is still the slope of my secant. The book's going to ask you, hey, let h equal 1 calculate. Let h equal 0.01 calculate. Let h equal 0.001 calculate. Do you need to do it by hand? No. That's what you calculate. Right? Use table feature and do calculate yesterday. Or go online and use that. But I got now the slope of the tangent equals the limit as h goes to 0 of star, which is 1 over 2 times 2 plus 0. which is 1 over 4. Again, notice when I put the 0 in, I'm not taking the limit anymore. Right? Here I'm saying, wait, let h go to 0. Let it go to 0, let it go to 0. Okay, done. Let it 0. I'm not taking the limit anymore. I know this way already. That's it? Yeah, of course. You don't have to, right? This is your class. You come and go as you please anytime. Even during a test. Yeah. 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 How to exactly get those? Yep. So the only denominator, the interior denominator. So there's 1, 2, 3. H over 1. So I take the 1, I take the 2, I take the 2 plus h and multiply it. It's usually a common denominator, not always an LCD. So that's the easiest way to think about it. Just multiply all the interior denominators together. Yes. I just want to keep things backward as much as possible. But, yes, but the 2 points are, one is fixed. One is fixed. Yeah. So we're going to move to a derivative where it's point anywhere. With this one, we started with 2 points. One of them fixed, one of them arbitrary. And then we came up with that replacement function. Right? We came up with that replacement function right here at star. And again, listen to it. The book is going to ask you, let h be 0.1, let h be 0.01, let h be 0.001. And you're getting secant slopes. And then when I finally say, well, can you take those secant slopes and predict? When you see it's getting closer and closer to 0.25, you will. But then let h go to 0, and you'll get the exact same. So, yes. What's that? Yeah, the arbitrary point is how far away from the original point. There was my first point, 1, x is 1. How far away is the other point? H. Let h be at 0.5, let h be 0.25, let h be 0.1, 0.01, 0.001. Yeah, anytime you need a break, anytime if you got a phone call, whatever, just feel free, go, okay? Let's set up number 5, okay? Number 5 says, I throw a ball in the air with a certain initial velocity of 40 feet per second. And I want to find the height. T seconds later is 40t minus 16t squared. Find the average velocity when t is 2, right? So what does this thing look like? 40t minus 16t squared. This is number 5. So 40t, sorry, it's not 40t, is it? Yeah. 40t minus 16t squared. Anybody recognize that negative 16? How about my physics major? Recognize that negative 16? Gravity in feet per second is negative 32 feet per second. So this is half of the force of gravity is that negative 16. What's it look like? Yeah, quadratic, right? I think 2 is about here. And they want the tangent line at 2, right? They want that slope at 2. If I throw a ball up in the air, right? If I throw a ball up in the air, yes? And if I do it while I'm moving sideways, you see the graph, right? So we're going to have an arbitrary point, right? And a fixed point of what? 2 comma what? Yeah, 40 times 2 minus 16 times 4, right? 80 minus, help me, 64? Yep. So 16, right? So that's our we're interested in that slope of the tangent line, but we got to get it from the secant line. So what's our secant slope going to be? Yeah, it's right. So the point is that one point is fixed, right? This other point is not. Yes? The other point is h, sorry, it's x plus h, comma, f of x plus h. But I know what x is. X is fixed at 2, right? So f of 2 plus h minus the fixed point all over 2 plus h minus 2, which turns out to just be 8. So that's where you're starting. Yes? What's that? Yeah. So the point I know is 2 comma 16, yes? And the point I don't know is h later, right? So 2 plus h is this point. 2 plus h. So I find, and let me write that, right? Let me write it so that you see it. So this is h, so this is 2 plus h. And this is 2 plus h, comma, f of 2 plus h. So if you look at my 2 points, I'm doing y2 minus y1 over x2 minus x1. Right? That helps? Yeah. Yeah. So look at what it's asking. Find the average velocity for the time period beginning when t is 2 and lasting 0.5 seconds. So h is 0.5 to start with. For part 2, h is 0.1. For part 3, h is 0.05. For part 4, h is 0.01. And then you're going to estimate, you're going to tell me where it's going. You're going to tell me the prediction. It'll probably be easier to use 0.1, 0.01, 0.001. You'll see a clearer pattern, okay? And then you can guess. But then what do I want you to do? What do I want you to do? Take that secant slope and take the limit of it. Right? Get that secant slope and get the limit of it. What do I have here? 40 times 2 plus h minus 16 times 2 plus h quantity squared minus 16 all over h. Right? You see? I'm doing the problem for you, but I don't care. I want you to understand it. Right? So this piece is factored, right? Yeah? Not factored. You gotta get this factored. Yeah. Yeah, exactly. Yeah, distribute, right? Distribute. Yeah. Foil, distribute. Combine, factor, simplify, take the limit. I'm nonstop today because I want to end as early as I can. But I'll start taking pretty normal breaks every class. Sorry, it's a little much. I know it. But I want to just push through a little bit more today and then quit early. Okay. Nice. Let me do one thing real quick. So again, if you go to YouTube and search for me, Robert Kuhar, you'll see all of the videos. The first video I recorded for us is 518. That was yesterday. Once they're uploaded, and it usually takes a day. That one just finished because I accidentally shut off my computer. I go to the schedule and I paste it here. So if you just go to the schedule, you'll see the videos a day later. Okay? The only class I'm teaching right now is this class. So the only videos I'm making are for this class. So if you go to YouTube and just subscribe every time a video is up, you know it's one of yours. Okay? So that way you don't have to wait for it. Just put it on the schedule. So you go to YouTube, search for Robert Kuhar, and the second one on the list right now. Okay? Nice. So what we just did is we had a fixed point. But what if we don't have a fixed point? That's what I want to talk about next. So we're talking about section 2.6 here. So we know that f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. My pen is leaking. When I'm teaching you how to do these derivatives, I'm also going to teach you shortcuts. So I'm going to teach you section 3.1 and section 2.6 at the same time. Some of you probably already know shortcuts. But if f of x is equal 3, what's f prime of x? Anybody tell me? Yep. So the first one is the line y equals 3, right? Yes? And what's the slope of that? Yep. And remember, the derivative is the slope at any point. Or the function that gives you the slope at any point. That's what the derivative is, right? F prime of x is called the derivative. It is the function that gives you the slope at any point x. So here we go. F of x is 3. I want f prime of x equal the limit as h goes to 0 of f of x plus h. What is f of x plus h? Here's f of x, right? What happens? What value do I get when I put in x plus h? 3. And the original f of x is 3 over h. So this is the limit as h goes to 0 of 0, which is 0. The slope of the derivative of a constant is 0. It's kind of nice on Desmos when I do this. I'll say f of x is 3, and d dx of f of x is 0. D dx is the operator take the derivative. So if I say d dx of y, it's the same as saying f prime. D dx is the operator. If y equals 2x minus 3, what's y prime? Anybody know it just by looking at it? 2? Yep. Makes sense, right? Yeah? Remember that y prime, or the derivative, or f prime of x, is the slope, right? So the limit as h goes to 0 of what? What's the first piece? What do I want to put in for the x? Good, x plus h, right? And then subtract off f of x, the original, all divided by h. F of x plus h minus f of x all over h. Yes, you with me? So what do I get here? I get 2x plus 2h minus 3 minus 2x minus 3 plus 3 all over h. Looks like the 2x's go away, the 3's go away. So I get 2h over h, which is 2. You with me? We okay here? Shortcut. What's the shortcut? The derivative of y equals mx plus b is m. The derivative of a constant is 0. The derivative of an mx plus b is m. How are we doing? We okay? One more easy one and then a tough one, okay? Ready? Anybody know the derivative already? Anybody know y prime or f prime of x? 2x. So we're doing the limit as h goes to 0 of x plus h quantity squared. That's x squared, right? But I put in x plus h, right? Minus an x squared all over h. Is this okay? Everyone okay with this? So star is x plus h quantity squared minus x squared all over h. I get x squared plus 2hx plus h squared minus x squared all over h. I just FOILed that piece out in my head. And I want to factor. What is 2x plus h? What does that represent? Slope of what? I didn't take the limit yet, right? So it's the slope of what? Secant line for some x and some h. To get the slope of the tangent line or the derivative, I let h go to 0. So f prime of x is the limit as h goes to 0 of star, which is 2x plus 0, which is 2x. There's the derivative. Everybody okay? Question? Yeah, so in line 3, line 2, yeah, x squared minus x squared, right? Watch. F of x, no, x squared, right? Yeah. Well, but at 0, can you see the tangent line? And we know the tangent slope is 2x, but x is 0. So 2 times 0 is 0. At 1, you see the tangent line there? Definitely positive. But we know that the derivative is 2x, so 2 times 1 is 2, the slope is 2 there. So the slope is variable. It changes as it moves, the slope changes. Let me create the tangent line real quick here. Just give me a second. Sorry. Oh. Sorry. So at 1, why won't it work? Why won't it work? Oh. Here it is. There's my slope. At 1, I get a slope of 2. At 0, I get a slope of 0, right? At negative 2, I have a slope of -4. Right? You see what's happening? It's a variable slope. All right, let's do a tough one. Seatbelts on. I like to, about 20 minutes before class starts, take 500 milligrams of Advil, because I know I'm going to have a headache, right? So I just try and stay ahead of it a little bit. And you can get them at Costco in a big thing, but you know, when you walk down the hallway, we'll hear you. Look familiar at all? It's from problem 3, 2.1 problem 3, right? So f prime of x is 1 plus x plus h. Oh, sorry, I need the limit. Limit as h goes to 0. 1 plus x plus h. Ugh, dummy. Sorry, it's just x upstairs, right? So x plus h over 1 plus x plus h minus x over 1 plus x, all divided by h. You with me? F of x plus h minus f of x, all divided by h. Right? So I start by writing the original function with every x replaced by x plus h. X replaced by x plus h. Minus the original function all over h. We're okay? Anyone not okay? You can just put out a sad sound or something. Anything. Everyone okay? I want to work on star separately. And when I'm doing this, I can see I have multi-terms. I want them wrapped. I need some help with my LCD. Anybody got it? Beautiful. And I want that over itself. Everybody comfortable with that? I look at my two interior denominators and I multiply them together to get the LCD. Sometimes it turns out to be a common denominator instead of a least common denominator. I'm trying to keep my colors together so that I can clearly show you that I'm distributing into the numerator here. Okay, you can clearly see I'm distributing those purple factors to the numerators of the numerator and to the numerator of the denominator, right? Numerator to the numerator, numerator to the denominator. Everybody okay? This is my favorite part. The canceling, yes. I use a red pen. Show the blood. And I rewrite nice and slow. I'm going to distribute. Upstairs only. Why? Why do I distribute upstairs only? Yeah, I want to get things factored so I can cross things out. I don't want to distribute downstairs to go back. I want to get things factored. You can see that algebra is hideous. Plus, you need patience. Don't save paper. Kill tree, pass the class. If you get a job, go plant a tree. Right? You're making $100,000 a year or something. Go plant a tree for all the paper you wasted in Cup 1. Cup 2, you might have to plant 2 more. This is the slope of a secant when I have a certain x and a certain h, right? But I'm interested in the derivative. And I got it. When I take that limit, I get my derivative. Remember the slope of the tangent line of all 3? Number 3. 1/4. And what was the x value? 1. So epsilon of 1 is 1 over 1 plus 1 from the square. 2 squared. So you see the difference between a fixed point and an arbitrary. This video is now. Do you have a headache, by the way? You should. Do you not have? Do you have a headache? You should. I mean, if you're a normal human being, we're not supposed to do this. We're not supposed to do 2 hours and 15 minutes of math nonstop. But summer class. What can we do? Nothing. We have to. I just did another 2 class. I did a whole other week of the semester. So